right, so we are on to question number 4 from the FRQ4 practice packet. Let's look at the first question. A says the functions g and h are provided, and the first part of A wants us to rewrite g of x as a single natural logarithm without any negative exponents in any part of the expression. So let's go ahead and let's do this. So when I'm looking at g of x, the first thing I'm going to do is I'm going to rewrite the coefficients and put them back into condensed form, making them exponents. So this 6 becomes an exponent on the quantity x minus 1. Now when I condense it, I know that subtraction turns into division, with the first number becoming the numerator, the first quantity, and the second quantity becoming the denominator. Let's look now at the second part of A. It says rewrite the function h of x as an expression in which the sign appears and no other trig functions are involved. So this is what I'm provided. I'm going to rewrite tangent as sine squared over cosine squared. So tangent squared is sine squared over cosine squared. On top I have sine squared and sine squared, making it sine to the fourth. And on the bottom I know that cosine squared is equivalent to 1 minus sine squared, and that's using that Pythagorean trig identity. So the two sine squareds provide me with sine to the fourth. And then I could leave it just like this, or maybe even if I wanted to break it apart. But I think specifically that they're probably going to want this version right here as, this version of x to the fourth, and whether I break it apart or leave it as 1 minus sine squared. Just make sure that if you break it apart, again, it's 1 plus sine of x and 1 minus sine of x. The 1 minus sine of x can go in the first part or the second quantity. Sometimes I see students, when they break this apart, they still include the square with the sign, and so this is a difference of squares. That's how we achieve this. So I believe that this would be correct. I also think they'd give you full credit if you left the denominator as 1 minus sine squared, and on top would have sine to the fourth. Let's look now at part B. All right, let's read the directions here. So part B specifically says the functions j and k are given. It provides us the functions j and k. And then the first part of B says solve when j of x equals 3 to the 2/5 for all values of x in the domain of j of x. So I'm going to take j of x that's provided, and I'm going to set it equal to 3 to the 2/5. Also, I know right now that x can be any value, positive, negative, and it can be any real value, positive, negative, or 0. Okay, so the first thing I'm going to go ahead and do, we know that there's no restriction on the domain of j of x, is I'm going to take this 3 to the negative 1, and when I move it up to the top, now the exponent becomes positive. I also know that when I have the same base and I'm multiplying, I'm going to add the exponent. So right now at this point, I'm going to work on adding these together. So 2x plus 1/5 plus 1, and that's what I go off and do here. I'm finding a common denominator, 5 times 5 times 5 times 5 times 5, and I end up with 10x over 5, 1/5, and 5 over 5. When I combine those, I get 10x plus 6 over 5, so I can now rewrite the quantity above as 3 raised to the 10x plus 6 over 5. Okay, how do we solve for x? Well, I'm going to take log base 3 both to the left and to the right, and I can see, let me grab a pen right now, or a pencil. I can see what I forgot to do here is I forgot to include this 3 right in this position. I forgot to include that 3 in my worksheet. Okay, log base 3 on the left, log base 3 on the right are going to be eliminated. I bring down 2/5 and I bring down this quantity. And now I'm going to cross multiply. Realistically, by the way, you can look that both denominators are the same, and so I can take 2 equals 10x plus 6, and so that's what I did. Or if you didn't know that, you could cross multiply and then simplify down. Subtracting 6 to both sides, dividing by 10, and then reducing that fraction. So x is equal to negative 2/5. That's the first part. That's the first part. If I move this down, that's the first part of B. Let's look at the second equation, which is on the back side of this. And let me go ahead and read this problem. Okay, the second part of this says, let me find it, it says k of x is equal to pi divided by 12 for all values of x in the domain of k. So I'm going to take k of x equals pi over 12, and I'm going to set it equal to what they tell me k of x is equal to. So we have the inverse sign of the quantity pi x minus 2 all divided by 6. So I'm going to start by moving that 6 to the opposite side by multiplying by the reciprocal, which is 6 over 1. I'm left with arc sine of pi x minus 2. And then when I reduce this down, I get 6 pi over 12, which is equal to 1 pi over 2. Now another way to represent arc sine would be inverse sine. And so I'm just showing that here. You could leave it as arc sine, or you could change it to inverse sine. My whole goal is to solve for x. So how do I remove an arc sine or inverse sine? I'm going to take the sine of both the left and right, keeping the equation balanced. On the right-hand side, the sine and inverse sine will be eliminated, and I'm left with the quantity pi x minus 2. And then I have to ask myself, what is the sine of pi divided by 2? Well, at pi divided by 2, and I didn't need this, by the way, at pi divided by 2, I have an answer of 1. I'm going to add 2 to the opposite side, and then divide by pi, and I get an answer of x equals 3 over pi. Let's look at part C. Part C directions are for the function m is given, and you can see this is the function m of x, and we're told that find all input values in the domain of m that yield an output value of 0. So m of x equals 0. So I'm going to replace m of x equaling this quantity with 0 equaling this quantity. And my first step is going to be to put this in condensed form. That means the 1/2 is going to become the exponent, as you can see. Remember, 1/2 as an exponent is the same as the square root of this quantity. And remember that subtraction, when we condense it, turns into division. This is what I have right now. Now, as a reminder, the base of the log and the value behind always have to be greater than 0. So I'm just reminding myself of that. And remember, we also know that the denominator can never equal 0 as well. Okay, so when I have this, I'm going to write it now in exponential form. It's base raised to an exponent. That's the value on the opposite side of the equal sign. So 7 raised to the 0 equals this quantity. Now, 7 raised to the 0 is 1. And now I'm going to do cross multiplying. So I'm taking 1 times this quantity and setting it equal to 1 times x. And now how do I solve for x? Well, I'm going to take the square of both the left and the right. That leaves me with the quantity 2x plus 8 on the left-hand side and x squared on the right. I'm going to take 2x, move it to the other side by subtracting, and 8 also move to the other side by subtracting. Now on the left-hand side, I have these two quantities that cancel out, and I have 0 equals x squared minus 2x minus 8. And now I'm going to go ahead and factor this and take each quantity and solve it. So that leaves me with x equals negative 4, x equals 4 and x equals negative 2. Don't assume just because it's negative, it's extraneous. I'm going to now try 4 and negative 2 into the original equation. So let's come back up here. And so remember, it says what are all the values within the domain. So domain is what can we plug in? What are we allowed to plug in? We need to make sure that whatever is directly behind the base, along with the base, needs to be greater than 0. So 4 was one of them. If I plug in 4, it's positive. 2 times 4 is 8. 8 plus 8 is 16, still positive. So 4 works. 4 is the solution. Negative 2 algebraically worked out, but when I plug it in, negative 2 cannot be the value directly behind. So that makes negative 2 an extraneous solution. It's important that you note that it's extraneous. So we have one answer then of x equals 4.